Hi everyone, welcome back to my YouTube channel. So I'm Ankit Mishra. I've been teaching gate chemical engineering for past 5 years. So today I'm bringing you a PYQ series for gate chemical engineering. So I've already uploaded many videos on mass transfer, process calculation, chemical engineering, and thermodynamics. So in this session I'll be discussing absorption mass transfer. So without wasting any time, let's start with the topic here. So first question of today's discussion is, again, this is a absorption. So benzene is in an air benzene mixture is to be reduced from 5.2 mole percent in the feed to 0.5 mole percent by contacting with wash oil in multi-stage counter current absorption. So let's say you have a absorption column something like that. Okay, and here you can see that benzene air mixture is being fed to this absorption column. Let's say this one is 0.1 and this one is top part is 2. So this one is my standard notation when I am solving any questions here in absorption. So here mole percent of benzene air mixture in benzene is let's say y1 is mole percent of benzene, so that is 0.052 and reduced from 5.2 mole percent in the feed to 0.5 percent. So here you can say that y2 will be equals to 0.005. Is that clear? Point 0.005. Okay, now the inlet flow rate of air benzene mixture is 10 mole per liter. So here you can see that G1 I can say that is 10 mole per second, and the benzene free wash oil here you can say that LS, that is benzene free wash oil, solute free, so that is your 9.5 mole per second. Okay, so this is how you have to write the questions, data from the questions in this way. And you can say that equilibrium line equation is given y star is equals to x, and from the graph also you can see. And here you are supposed to calculate number of equilibrium stages required to achieve the above conversion. So it's fine. So first you'll calculate the capital Y1. So what is capital Y1? So that is 0.052 divided by 1 minus 0.052. So what is capital Y1? That is the mole ratio. So data has been given in terms of mole fraction, and you are supposed to calculate in mole ratio, solute free basis, right? So capital Y1 you will be getting 0.0548, right? Now when it comes to capital Y2 will be equals to 0.005 divided by 1 minus 0.005. So I think this is very dilute system. So you have to calculate. So the value will be equals to 0.0050, something like that. Okay, so that will be equals to 0.0050. Now once we have calculated this one, and again here you can see that x1 equals to 0, right, and x2 you don't know. Okay, first thing. Second thing is that what is ls? So sorry, gs can be written as g1 into 1 minus a small y1. So g1 is 10 into 1 minus 0.052. So if you'll calculate these things, 1 minus 0.052 multiplied with 10. So here you will be getting 9.48. So that will be equals to 9.48. Is that clear? So this is approximately equals to 9.5 you can say, right? Approximately 9.5. Okay. Now if I calculate ls by gs, so that will be approximately equals to 9.5 divided by 9.5, that is equals to 1. So what is absorption factor? That is equals to ls divided by mgs, that is equals to 1. So if absorption factor is 1, then you can calculate number of stages, that is equals to y1 minus y2 divided by y1 minus y1 star, or equals to y1 minus y2 divided by y2 minus y2 star. And this formula is only valid when absorption factor is 1, right? Because slope of your operating line and the equilibrium line will be parallel. So let's say this one is the operating line and this one is equilibrium line, so this is parallel. So that's why you can write this formula. This formula is only valid when absorption factor is equals to 1. Now you can see that if y1 x1 is equals to 0, then x y1 y sorry so sorry this will be x2 and this will be x1. So x2 is 0 here, so what will happen, y2 star will be equals to 0. So can I say that y2 star will be 0? Why? Because equilibrium relation is given as y equals to y star is equals to x. So if I want to write y2 star, that is equals to x2, which will be equals to 0. So I can use this formula. This is very simple. So now directly I can write n is equals to y1 minus y2 divided by y2 minus y2 star, and y2 star is equals to 0. So directly I can write y1 minus y2 divided by y2. So it can be written as y1 divided by y2 minus 1. So that is n. So now n can be written as, what is y1? So capital Y1 is 0.0548. So I can substitute 0.0548 divided by what is Y2? Capital Y2 is 0.005 and minus 1. So if you will calculate these things, 0.05 multiplied with 0.0548 minus 1. So this value you will be getting, that is equals to 9.96, something like that. So 9.96. So if that is approximately equals to 10. So number of ideal states that is required here is 10. And this formula that I have told you, so you have to understand, and you can be very smart when you are doing the calculation. So this is very important thing. And if you want to learn how to do the calculation the way I am doing these things, it is going to help you a lot when you are solving actual GATE examination. So I am trying to simplify the calculation also. A major part of your solution will be going in the how you are approaching or how you are applying the aptitude there, right? So obviously concept but from the concept, once you extract all of these data and once you apply the formula, calculation part plays a very crucial role when you are solving the GATE paper, right? So this is how you can do this thing, right? After that, I'll be moving towards the next problem of today's discussion, and the question says that this is a theoretical question. So here you can see this question says, in a counter current gas absorber, both the operating and equilibrium relations are linear, right? Operating and equilibrium lines are linear. The inlet liquid composition and the exit gas composition are maintained at constant in order to increase the absorption factor. So first here you have to understand what is absorption factor. Absorption factor used to be equals to LS divided by MGS, or you can say that LS divided by GS, that is slope of operating line divided by slope of equilibrium line. So you want to increase the absorption factor. So absorption factor is a function of LS, GS and M. So either you can increase the LS, decrease the GS, or decrease the M. All of these three things you can do, and after doing these things you can get you can increase the absorption factor. So here you can see the liquid flow rate should be decreased. No, that is wrong. Why? Because you want to increase the absorption factor. So if you will decrease the liquid flow rate, then definitely it is going to decrease the absorption factor. Next is the gas flow rate should increase. So again, if you will increase the gas flow rate, what will happen? The absorption factor will decrease. The slope of equilibrium line should increase. Again, this is wrong. Why? Because if you will increase the slope of equilibrium line, then absorption factor will decrease. So last option, the slope of equilibrium line should decrease, then absorption factor will increase. So your option D will be your correct answer. This is very simple and fundamental question, but again, this question can be asked in 1 marks, but now these days they are not asking this kind of question. GATE got to a good level. They are GATE is putting now good level of questions. That's why you have to understand the tough concept also. Now moving towards the next question. The question says that the ratio of the liquid to the gas flow rate in the counter current absorption column is increased. So let's say ratio of liquid to gas flow rate in counter current column absorption is increased. So LS by GS is increasing, right? So here you can see the operating line shift towards the equilibrium line. So when we talk about this one, and what is equilibrium line and M. So what is slope of operating line? Slope of line equals to LS divided by GS. Is that clear? So if I am talking about LS divided by GS, so if this is the equilibrium line, let's say equilibrium line, and this one is, let's say, operating line. And what is the slope? Ls divided by gs. So if I'll increase ls divided by gs, what will happen? Operating line slope will increase and it will shift away from the equilibrium line, right? So just see what which options will be correct. The operating line shifts towards the equilibrium line, that is wrong. The operating line shifts away from the equilibrium curve. The operating line shifts away from the equilibrium curve. This can be correct. The concentration of the absorbed species increases in the exit concentration. The operating line does not shift. So next C and D will be your incorrect, right? So option B is correct. Okay. Now moving towards the next question, and here you can see the question says that the packing of an existing absorption tower is replaced. Again, this is a theoretical question. Replaced with a new type of packing. The height of the packing and the inlet conditions are maintained at the same as before. So here you can see, here it has been so HTU is maintained same. Test reveals that the number of transfer unit is lowered. So NTU is getting decreased and HTU is constant, right? This indicates that the tower with the new packing, when compared to that with the old packing, will have a higher rate of absorption of the solute from the gas stream, have lower rate of absorption of the solute from the gas stream, the same rate of absorption of the solute from the gas stream. And sorry, here STU is not fixed, height of the tower is fixed, so height is constant. If height is constant, then what is height of the tower? Height is your HTU multiplied with NTU. Is that clear? So if H is constant, NTU is decreasing, right? Sorry, NTU test reveals that number of transfer units is lower than before. Okay, NTU in the next case is lower than the STU. So again, in the next case, what will happen? Height of transfer unit should increase, right? Then only this can be constant, right? So here you can see that have a higher rate of absorption of the solute from the gas system, and this indicates that tower with the new packing, when compared to the old packing, will have a lower height of the transfer unit, right? Because it should increase the STU, but again this is not going to increase. That's why you have a lower unit of transfer unit. Okay. Now, moving towards the next question. Next question says that packed tower are preferred for a gas liquid mass transfer operation with foaming liquid, because in packed tower high liquid to gas ratios are best handled. High liquid to gas ratios are best handled. That is wrong. That is not possible in packed tower. This can be true for the tray tower. In packed tower, continuous contact of gas and liquid takes place. Again, continuous contact, it is taking place, but again it's not like that in case of the way continuous contacting is taking place in the gas liquid in tray tower. This is also wrong. Packed tower are packed with the random packing. No, it is not like that. There are different kind of packing also that exist. That's why this is not universally correct. And in packed tower, the gas is not bubble through the liquid pool. So I think this is correct, because in packed tower gas is just moving, gas and liquid contact is happening during the packing, over the packing. But in this, option 4 is correct when it is applicable. This is applicable only for the tray tower, where you can see this tray will be looking like that, and what is happening, liquid is flowing like that over the tray, and now gas will be flowing from this perforation, right? So in packed tower, the gas is not bubble through the liquid pool. This is true because here you can see in plate tower only the gas is bubble through the liquid pool, right? So from here, option D will be correct. Moving towards the next problem. Again, this is good question asked in 2015. So this question says that benzene is removed from air by absorbing it in a non-volatile wash liquid. The total pressure of countercurrent absorber is 100 kilopascal. Gas flow rate is 100 mole per minute, which includes 2 mole per minute of benzene, right? So first try to understand what is happening here. So this one is a tower, okay? So if I am assuming this one is first point and this is second point. So here benzene air mixture is introduced here, inlet. So obviously, and here wash oil is being used. Okay, so here you can see the total pressure of this system. Pressure is your 100 kilopascal, and the benzene from, obviously you can see the flow rate of wash oil is 50 mole per minute. Okay, before that you can see the gas flow rate is 100. So gas flow rate will contain obviously benzene and air. But if you are going to write in terms of solute free, that if you are removing benzene, so what will be the flow rate of the gas? Ls will be equals to 100 minus 2, that is 98. So here I can write Ls will be equals to 98 mole per minute. Okay, fine. Now which includes the flow rate of wash oil is 50 mole per minute, right? The flow rate of wash oil, here wash oil is being used, so Ls is equals to 50 mole per minute. Vapor pressure of benzene at the column condition is 50 kilopascal. So P saturation is given to you. P saturation is equals to 50 kilopascal. Great. Benzene form an ideal solution with the wash oil and the column is operating at a steady state, obviously, and gas phase can be assumed to follow an ideal gas law. Neglect the change in molar flow rate of the liquid and gas phases inside the column. Okay, gas flow rate and liquid flow rate is not going to change. For this purpose, the value of absorption factor. So you are supposed to calculate the value of absorption factor. Okay, great. So what is absorption factor? So absorption factor is equals to slope of operating line divided by slope of equilibrium line. Okay, and slope of, what is slope of operating line? Slope of operating line is equals to Ls divided by Gs, and you know Ls is your 98 and what is Gs? Gs is 50, right? So you can calculate, this will be equals to 1.19. Sorry, 1.96. 1.96. Okay, you know, slope of operating line you have calculated, and now coming to slope of equilibrium line, that is equals to what? P set divided by P total, if we are using Rolle's law. What is equilibrium line? So this line will be between y and x. So let's say this is equilibrium line, something like that. So y into pt equals to x into p set. So y equals to p set divided by pt into x. So what is y? Y equals to mx. So m is slope. So what is m? M is p set by pt. So you can say what is p saturation? P saturation is given to you in the problem, that's 50, right? So this one is 50 divided by 100, that is equals to 0.5. So what is absorption factor? That is equals to 1.96 divided by 0.5, and that will be equals to 3.92. Is that clear? So from here you can get the absorption factor will be equals to, I think I have done some mistake somewhere. So sorry, this is Gs actually. This is Gs and that is Ls. So here this will be opposite. So that will be equals to 50 by 98. Okay. So now I'll be substituting these things here. 50 divided by 98 multiplied with 0.5. That will be 100 divided by 98. If you calculate, this value will be 1.0. Is that clear? This was really a good question, but this was based on the liquid vapor equilibrium also. So here you can see that you can use the Rolle's law also, because you are supposed to follow the ideal gas equation, and that's why I have substituted this in. Now moving towards the next question, that is, this question has been asked in 2017. Again, IIT Roorkee made the question that year. So this year also IIT Roorkee is going to organize the gate. So these kind of questions can be asked. In a counter current stripping operation, so if I am talking about a stripping, so where the solute is being transferred from liquid to gaseous phase, right? Here you can see. So here liquid will come, gas will leave, gas is coming and liquid is leaving. So let's say this one is 0.1 and this one is 0.2. This is my standard notation. and the mole ratio of solute in the liquid stream is reduced from 0.25 to 0.5 mole ratio. So let's say here x2 is given to you, that is 0.25, and obviously x1 is equals to 0.05. The liquid feed flow rate are on the solute free basis, so ls is given to you, that is 3 mole per second solute free basis. The equilibrium curve is given, that is this one. The minimum flow rate of pure stream for this process, so you are supposed to calculate minimum flow rate of pure stream for this process. GS minimum you are supposed to calculate. Is that clear? Okay, GS minimum. So how we will calculate this thing? So when we write the formula ls divided by gs, that used to be equals to y1 minus y2 divided by x1 minus x2. Is that clear? This is my equation first, and if I am writing ls divided by gs minimum, that will be equals to y1 minus y2 max divided by x1 minus x2. Is that clear? Why y2 max? Because this is getting transferred from here to here. So y2, what will be the value of exit concentration of solute in the gaseous phase with respect to the GS minimum? So how much GS minimum that should be supplied, that maximum concentration of solute in the gaseous phase can be achieved. This is second. So if I'll divide equation first and second, what will I get? That before that, first I have to calculate the equilibrium relation. So from here, what you can see, what is slope of equilibrium line? Slope of equilibrium line is equals to y by x. So 0.15 divided by 0.25, 3 by 5, that is equals to 0.6. So y will be equals to 0.6x, right? So this one is the equilibrium line y star. So here what you can see, that we are supposed to calculate GS minimum. So here we don't know, the liquid feed flow rate is given to you, okay, it's fine, and this concentration is given to you, x1 and x2 is given to you. Is that clear? So if I want to calculate y2 max, that is 0.6 multiplied with x2. So I can write y2 max, that is equals to 0.6 multiplied with, what is x2? x2 is given to you, that is 0.25. Is that clear? So 0.25. So if I'll divide this equation, that GS divided by GS minimum divided by GS, that I can write, that is your y1 minus y2 divided by y1 minus y2 max. So y2 max we have already calculated, and now the thing is that how can we calculate the value of y1? Okay, okay. So here you can see that y1 will be 0, because liquid stream is reduced from the liquid fluid flow, y1 will be 0. So yeah, so if y1 I'll be making 0, so from here you can calculate GS. So if I want to write ls divided by GS, that will be equals to y1 minus y2 divided by x1 minus x2. So y1 will be equals to 0. So ls is 3. We can calculate GS from here, that is equals to minus y2 divided by x1 minus x2. And what is y2? y2, or directly I can substitute these things. Ls divided by gs mean that is equals to y1 minus y2 max divided by x1 minus x2. That's it. Is that clear? Y1 is 0 and y2 max. So ls is 3, gs minimum we are supposed to calculate, that is equals to y2 max. Y2 max we have calculated, that is minus 0.6 multiplied with 0.25. And what is x1? X1 is given to you, that is 0.25, sorry, x1 is 0.05 and x2 is 0.25. So you can say 0.05 minus 0.25. So what is gs minimum? Then that is equals to 3 multiplied with 0.20 divided by 0.6 multiplied with 0.25. Is that clear? So that is equals to 3 into 4 into 10 divided by 6 into 5. So this is 3 cancel. So that will be 4. So your gs minimum, that is equals to 4. So see, one thing is that why I was searching for lots of these data, but I was searching for lots of these data, but you don't require this kind of data. Directly you can calculate from this formula only, right? So if this is going to click you during the examination, then definitely you are going to save lots of time. But here you have seen that I was wondering for some more data, but ultimately I found, okay, this is the trick that I should use this. So that's why I have lost 1.5 minute there for wondering for lots of these data that is not required. So these kind of thing that you have to figure out during the process, and this will only come when you are practicing a lot for the problem. Now coming to the next problem, this question says that a counter current absorption tower is designed to remove 90% of the 95% of the component. So there is a counter current absorption tower. So most of the time you will see the question is coming from counter current. So in counter current, gas will flowing from here, the gas is going to exit from here, liquid is coming here and liquid is exiting here. So if I am assuming this one is my point 2 and this one is my point 1, so remove 95% of the component. So recovery is 95%. So okay, I'll tell you these things. So if this one is x1 and this one is x2, so x2 will be equals to 0.05 x1. That's it. This is the sentence that has been written in the first line. And incoming gas mixture solvent with the mole ratio of A in the inlet gas stream is 0.02. So here, oh sorry, so this is y and this is x. So this is y1, this is y2, this is x2 and this is x1. So y1 is given to you how much? 0.02 in terms of mole ratio. The carrier gas flow rate is 50 mole percent. So G1 is given 50 kilomole per hour. The equilibrium relation y equals to 2x is given to you. The mole ratio of A in the gas and liquid phases respectively if the tower is operated at the twice the minimum solvent flow rate. So this one is, let's say, ls is equals to 2 multiplied with ls minimum. The tower is operating in this way. So the mole ratio of A in the exit liquid stream. So you are supposed to calculate x1 equals to what, and x2 will be equals to 0, right? So you are supposed to calculate x1 equals to what. So if I want to write this equation, ls divided by gs, that can be written as y1 minus y2 divided by x1 minus x2. This is equation first. And if I want to write ls minimum divided by gs, I can write y1 minus y2 divided by x1 minus x2 max. Sorry, x1 max minus x2. This is my equation second. So if I'll divide my equation first and second, what will I get? I'll be getting ls divided by ls minimum, that is equals to x1 max minus x2 divided by x1 minus x2. Okay, great. But here you can see that x2 is 0. Sorry, x2 is 0. So that is 0, that is 0. So that can be written as x1 max divided by x1. And how we can calculate x1 max? So that can be calculated as y equals to 2x. So this equilibrium relationship is given y equals to 2x. So what is x1 max? So x1 max will be equals to y1 by 2. And what is y1? Y1 is 0.02. X1 max is 0.01. So now you can write, and LS is equals to 2 of LS minimum. So that is equals to 2, that is equals to so you are supposed to calculate the mole ratio of A in the exit liquid extreme x1, right? So x1 we don't know, x1 max we have calculated 0.01 divided by x1. What is x1? X1 will be equals to 0.01 divided by 2, that is equals to 0.005. So that will be equals to 0.005. So here you will be getting the value 0.005. So this is very simple question, but you have to understand how I am using, which kind of formula that is being used. So I mean, most of the time you will see this, all of these questions are coming from the same formula. So if you know this formula, then definitely it is going to click you in the examination. Okay. Now moving towards the next question. The next question says that in a solvent regeneration process, a gas is used to strip a solute from a liquid in a counter current packed tower operating under the isothermal condition. Pure gas is used in the stripping operation. All solutions are dilute and Henry's law is applicable. Y star is equals to mx. Here Y star is the mole fraction of the solute in the gas phase in the equilibrium with the liquid phase of the solute mole fraction x, and m is Henry's law constant. So let x1 be the mole fraction of the solute in the living living liquid, and x2 is the mole fraction of solute in the entering liquid. So just try to understand one thing. This is a very different thing. So here it is saying that x1 is the mole fraction of the solute in the living liquid stream. So here x1, this one is 0.1 and this one is 0.2, and x2 is the mole fraction of liquid in entering liquid stream. So x1 and x2 we have written. So here there will be a y1 and obviously there is a y2. Now when the value of the ratio of the liquid to gas molar flow rate is equals to m, means absorption factor is equals to 1. So what is the NTU-OL? So when we talk about NTU-OL, just in the previous last to last question I have seen, you would have seen that if absorption factor is equals to 1, then you can write the NTU-OL formula, that is equals to x1 minus x2 x2 minus x1 divided by x2 minus x2 star, or that is equals to x2 minus x1 divided by x1 minus x1 star. Is that clear? But here what you can see that when we talk about the y1 star, so there will be y equals to mx relation, right? If absorption by m is equals to 1. So in that case what will happen, since y1 is equals to 0, then what will happen? x1 star will be equals to 0. Why? Because y1 equals to 0, right? So if x1 star is equals to 0, so in that case what I can write here, that formula for NTU-OL, that will get reduced in this form, x2 minus x1 divided by x1. So here you can see which option is your correct option. So here you can see x2 minus x1 by x1, this option A will be your correct answer. It's very simple question, but again the question was from this formula. This is applicable for when absorption factor is equals to 1. So here solute were getting transferred from liquid phase to gas phase, and this is called as a stripping. Now moving towards the next problem, and this question says that a packed distillation column with vapor having an average molecular weight of vapor is given 45 kg per kilomole, and the density is given to you, that is 2 kg per meter cube, and a molar flow rate of 0.1 kilomole per second. So let's say vapor molar flow rate will be equals to 0.1 kilomole per second, has a flooding velocity is given to you, UF. Let's say UF is equals to 0.15 meter per second, and column is designed to operate at a 60% of the flooding velocity. So operating velocity of column is 0.6 multiplied with U flooding. So you are supposed to calculate the column diameter. So when we talk about vapor flow rate, can be written as A into rho into cross sectional area into U operating velocity. Is that clear? So vapor flow rate is given is how much in 0.1 kilomole per second. That is density is given in terms of 2 kg per meter cube. So if I'll divide density by 45 kg per kilomole, so that will be in kilomole per meter cube. So unit will be you have to understand the dimensional homogeneity also. The dimensions of LHS should be equals to dimensions of RHS, and area of cross section can be written as pi by 4 into diameter of column whole square into operating velocity will be equals to 0.15 multiplied with 0.6. Is that clear? It's very simple now. So if I want to calculate the value of dA star from here, dA square, so I can write 0.1 into 45 into 4 divided by 2 multiplied with pi into 0.15 into 0.6. Is that clear? This is just a simple calculation now. So if you will do the calculation, so you can write dA square is equals to 45 into 4 into 100 divided by 2 into pi into 15 into 6, like that. So you can see that this will get cancelled out, and this 3 into 4 12, 6 into 2 12. So diameter will be equals to 100 divided by pi root over that is equals to 10 divided by root pi. Is that clear? So this will be your answer. So just check your option, which of the following option is correct. I think 10 by root pi, option D is your correct answer. Is that clear? Okay, so this one is the last question that is asked in 2023, and after that I think I'll be able to complete the PYQ of this thing, absorption. So this question says that a liquid L containing a dissolved gas S is stripped in a counter current operation. So again this question is from stripping. So you can see maximum question is coming from absorption and stripping, and this all of these questions are coming from the same formula, but you have to understand we have to use how to use the formula. The current operation using a pure carrier gas V. So here there is a pure carrier gas V. So here I am assuming y1 that is equals to 0. So if this point is my 1 and this is the second point, entry and exit. So whenever I am talking entry, that is 1, and whenever I am talking about the exit of the gas, that is 2. So this is the standard notation that I am using. The liquid phase inlet and outlet mole fraction of S are 0.1 and 0.2. So here inlet, let's say x2 is equals to 0.1 and obviously x1 equals to 0.01. So this is in mole fraction. The equilibrium distribution of S, that is y equals to S. Equilibrium relation is y equals to x. And the mole fraction of VLN, the molar feed rate of the carrier gas stream is twice as the liquid. So here you can see Z equals to 2 multiplied with L. The molar feed rate of carrier gas stream is twice as the liquid stream. Under dilute condition, if it is dilute condition, then what will happen? Mole ratio will be equals to mole fraction. The minimum number of stages is required. Okay, fine. So when we talk about the dilute condition, no? So in that condition, what you can see that this is a stripping. So otherwise, two case can happen. So equilibrium relation is y equals to S, but problem is that okay. So here you can say that Ls divided by Gs will be equals to 2. So equilibrium line is this. Slope of equilibrium operating line is 2 and slope of equilibrium line is 1. So what is absorption factor? Absorption factor is equals to 2. So what is a stripping factor? That is equals to 1 by 2. Okay, so here you can see absorption factor is not equals to 1. So this is the problem where you cannot use y1 minus y2 divided by y1 minus y1 star. So in this particular problem you have to use the Cramsers-Brown equation, that is the formula. So when we use this formula for number of stages calculation, the formula used to be ln x. So here you can say x2 minus y1 divided by m, okay, into 1 minus 1 upon s plus 1 by s, and here divided by x1 minus y1 divided by m, okay, and divided by ln s. So you know what is x2, x1, y1, y2. So now you will substitute value ln. What is x2? Because this is dilute system, so x2, small x2 and capital X2 will be same. So 0.1. So 0.1 minus y1. So y1 is solute free, so that is 0 divided by x1 is 0.01 minus 0 into 1 minus 1 by 2. Sorry. So 1 minus 1 by 2 plus 1 by 2 divided by ln 2. So if you will calculate these things, np equals to ln 0.1 divided by 0.01 into 1 by 2 plus 1 by 2 divided by ln 2. Sorry, here it will be in the formula it will be s only. 1 minus s plus s. So that is 1 by 2. And once you will do the calculation, np can be written as, you will get 2.46, which is equals to 3. So 3 stages will be required to do this kind of stripping for transferring solute from liquid phase to gaseous phase. So this is all about the absorption topic. Now I have completed the absorption. In the next lecture I will be discussing the previous year question of membrane separation, and after that I will be starting the PYQ series of fluid mechanics, and I'll completely, I mean, in a detailed way, I'll be talking about the PYQ series of fluid mechanics, where you will be learning a lot. So I'll suggest you just go and try to watch all of these lectures and try to subscribe video, and also share with your colleagues, so that those who are not able to avail with the big institute, they can watch all of these video and they can learn them. Thank you.